The universe is vast in a way that defies intuition. When you look up at the night sky, what you are seeing feels enormous. Thousands of stars scattered across a dark canvas. But that view is deceptive. What your eyes perceive is only the nearest surface of a much deeper reality. Beyond those visible stars lie countless more, hidden by distance, dust, and time. Our galaxy alone, the Milky Way, contains more than 400 billion stars. Each one is a sun. Around many of them, planets move silently through space, bound by gravity, warmed by starlight, shaped by chemistry. And beyond our galaxy lie hundreds of billions more galaxies, each filled with their own oceans of stars. The scale is almost unbearable to comprehend. For most of human history, we believed Earth was unique, a rare oasis of life in a hostile universe. But modern astronomy has dismantled that idea completely. We now know that planets are not rare, they are common. They form naturally wherever stars are born. Rocky planets, ocean worlds, frozen moons, worlds with thick atmospheres and violent storms, worlds bathed in radiation, worlds warmed gently enough for liquid water to exist on their surfaces. In other words, worlds where life could begin. And life, once it starts, has a tendency to persist. On Earth, life emerged almost as soon as conditions allowed it. Simple organisms appeared quickly, adapted relentlessly, and survived catastrophic impacts, volcanic winters, ice ages, and mass extinctions. Life did not just survive, it diversified, complexified, and eventually became intelligent enough to ask questions about the universe itself. This leads to an unavoidable expectation. If the universe is this old, and this large, and this filled with planets, then intelligent life should not be rare. It should be common. There should be civilizations far older than ours, civilizations that mastered energy on planetary scales, civilizations that learned to travel between stars, civilizations that reshaped their environments in ways visible across vast distances. And yet, when we look into the cosmos, we find nothing. No signals, no structures, no unmistakable evidence of intelligence beyond Earth. The universe is silent. This silence is not neutral. It is not just an absence of noise. It is a contradiction, a conflict between what we expect to see and what we actually observe. Because even a single advanced civilization, given enough time, should leave traces everywhere. 1,000,000 years is nothing on cosmic timescales. 1,000,000,000 years is less than the age of most stars. If a civilization had emerged in our galaxy long before us, even a fraction of a percent earlier, its presence should be obvious by now. But the sky remains unchanged. This disturbing mismatch between probability and observation is known as the Fermi Paradox. It is not a paradox because aliens must exist. It is a paradox because, statistically, they should have already made themselves impossible to ignore. And yet, here we are, alone, listening, waiting. Consider this for a moment. Humanity has been using radio technology for just over 100 years. Our radio signals have expanded outward in a thin, spherical bubble traveling at the speed of light. That bubble is now roughly 100 light years in radius. In galactic terms, that is microscopic. If another civilization were even a few thousand years ahead of us, a blink of an eye in the life of the universe, their technological footprint could span the entire galaxy. We should see something, but we don't. This is where the mystery deepens. Because the more we learn about the universe, the less sense the silence makes. Every new discovery increases the number of places life could exist. Every new exoplanet strengthens the argument that Earth is not special, and every chemical signature found in distant atmospheres suggests that the building blocks of biology are everywhere. And yet, intelligence appears absent. This raises a chilling possibility. What if the universe is not empty because life never arises? What if it is empty because life does not last? What if there is something built into the nature of intelligence, technology, or civilization that leads inevitably to collapse? If that is true, then the silence we observe is not random.
it is a warning, and understanding it may be the most important challenge humanity has ever faced.
The story of this mystery does not begin with telescopes or spacecraft. It begins with a lunch conversation. In the summer of 1950, a group of physicists were eating together at Los Alamos National Laboratory in New Mexico. These were not ordinary scientists. Many of them had worked on the Manhattan Project. They were men who had helped unlock the power of the atom and reshape the modern world. Among them was Enrico Fermi. Fermi was one of the most brilliant physicists of the 20th century. He was known for his ability to strip complex problems down to their core using logic, estimation, and intuition. He was not a man prone to wild speculation or science fiction fantasies. During the lunch, the conversation drifted toward reports of flying saucers and the possibility of extraterrestrial life. At first, it was casual, almost playful. Then, Fermi stopped. He thought for a moment, and he asked a question so simple, so direct, that it immediately changed the tone of the room. Where is everybody? The question landed with unexpected weight. Fermi was not asking whether alien life might exist somewhere. He was pointing out something far more troubling. If intelligent civilizations were even moderately common, and if technological progress followed a similar path to our own, then the galaxy should already be filled with their presence. The Milky Way is vast, but it is not infinite. It contains on the order of 400 billion stars and has existed for more than 13 billion years. Even traveling at speeds far below the speed of light, a civilization with basic interstellar capability could spread across the galaxy in a few million years. A few million years. That is less than 1/10 of 1% of the galaxy's age. So if intelligent life arose anywhere in the Milky Way long before humans appeared, then by now the evidence should be everywhere. But it wasn't. No alien probes orbiting the sun, no visitors recorded in human history, no obvious technological structures visible in the sky. Just stars behaving exactly as nature predicts. Fermi's question exposed a contradiction that no one in the room could easily dismiss. It wasn't philosophical, it was mathematical, and once it was asked, it could not be unasked. Over time, this contradiction became known as the Fermi Paradox. It sits at the intersection of astronomy, biology, physics, and probability. And it grows more disturbing with every scientific advance. Because the paradox does not weaken as we learn more about the universe, it strengthens. To understand why, scientists began to formalize the problem. In 1961, astronomer Frank Drake introduced an equation, now known as the Drake equation, designed to estimate the number of technologically advanced civilizations in our galaxy. The equation breaks the problem into steps. How many stars are born each year? How many have planets? How many of those planets are habitable? How often does life arise? How often does intelligence develop? How long do technological civilizations last? Each factor carries uncertainty, but when scientists began filling in realistic values, something remarkable happened. The answer was rarely zero. Even with conservative assumptions, the equation suggested that the Milky Way should host multiple intelligent civilizations at any given time. And yet, observation tells a different story. We see no evidence of galactic engineering, no energy-harvesting megastructures, no unmistakable signals crossing interstellar space. The paradox deepened further as technology improved. Radio telescopes became more sensitive, surveys expanded, Astronomers scanned the skies across multiple frequencies, searching for artificial signals that natural processes could not produce. Decades passed. Still nothing. At the same time, our understanding of planetary systems exploded. In the early 1990s, the first exoplanets were confirmed. At first, scientists thought these discoveries might be rare or unusual, but as detection methods improved, planets began appearing everywhere. They were not exceptions, they were the rule. Planets formed naturally around stars of all types: small stars, large stars, old stars, young stars. Many stars hosted multiple planets. Some systems contained dozens. This discovery shattered one of the last comforting assumptions, that Earth might be exceptionally rare. Instead, Earth appeared typical, one rocky planet among billions. And if Earth is typical, then life may be common, which makes the silence harder to explain. By the early 2000s, the Fermi Paradox was no longer a fringe curiosity. It became a central question in astrobiology and cosmology. Why does the universe look empty when it should be crowded? Why do we see no traces of civilizations that should have had millions or billions of years to leave their mark? The answers proposed ranged from hopeful to horrifying. Some suggested that advanced civilizations deliberately hide. Others proposed that interstellar travel is far harder than we imagine. A few argued that humanity might be the first intelligent species to arise in the galaxy. But none of these explanations fully resolved the contradiction, because they required assumptions that were increasingly difficult to justify. As evidence accumulated, one idea began to dominate serious discussion, an idea that reframed the entire problem. Perhaps civilizations are common. Perhaps intelligence arises frequently. Perhaps technology develops naturally. But perhaps something happens next, something that prevents civilizations from surviving long enough to spread across the stars. This idea would become known as the Great Filter. And once scientists began examining it closely, the implications became deeply unsettling. Because the Great Filter does not just explain the silence, it may explain our future.
By the early 21st century, the search for planets beyond our solar system had transformed from speculation into precision science. New space telescopes and ground-based observatories began surveying the sky methodically, star by star, measuring tiny dips in brightness as planets passed in front of their suns. These transits revealed not only the presence of planets, but their sizes, orbits, and in some cases even the composition of their atmospheres. The results were staggering. Astronomers discovered that planets are not rare accidents, they are the natural outcome of star formation. Nearly every star in the Milky Way hosts at least one planet, and many host entire systems of them. Among these worlds were countless rocky planets roughly the size of Earth. Even more surprising, a significant fraction of them orbit within what scientists call the habitable zone, the region around a star where temperatures allow liquid water to exist on a planet's surface. Liquid water is not a guarantee of life, but on Earth it proved essential. Where there is water, chemistry becomes dynamic. Molecules interact, replicate, and evolve. As planet catalogs grew, so did the number of potentially habitable worlds. By conservative estimates, there may be tens of billions of Earth-like planets in our galaxy alone. This realization deepened the paradox. If environments suitable for life are everywhere, then the emergence of biology should be common. And if life is common, then intelligence should arise occasionally. And if intelligence arises, technology eventually follows. The chain seems inevitable, and yet somewhere along that chain, something breaks. To understand where, scientists turn to Earth itself. Our planet is not just a place where life exists, it is a record of survival through catastrophe. Life on Earth endured massive asteroid impacts, supervolcanoes, global glaciations, and atmospheric collapse. Entire branches of evolution were erased, only for new forms to rise in their place. The extinction that wiped out the dinosaurs did not end life. It created the conditions for mammals and eventually humans to emerge. This suggests that mass extinction alone is not enough to permanently erase life. Life, once established, is remarkably resilient. So perhaps the filter does not lie in the early stages. Perhaps simple life is easy. Perhaps complex life is common. Perhaps even intelligence is not the true bottleneck. This shifts attention to a more dangerous stage, the transition from intelligence to advanced technology. On Earth, that transition happened rapidly. For hundreds of thousands of years, humans lived as hunter-gatherers. Then, in just a few thousand years, a blink in evolutionary time, we developed agriculture, cities, industry, and global civilization. In just 2 centuries, we unlocked fossil fuels, electricity, nuclear energy, and digital computation. Our technological power now rivals natural forces, and with that power comes risk. For the first time in Earth's history, a single species possesses the ability to permanently alter the planet's climate, trigger global ecological collapse, or end civilization through warfare. From a cosmic perspective, this phase may be extremely dangerous. A civilization that reaches industrial and post-industrial technology gains enormous power before it gains the wisdom to control it. If this pattern is universal, then many civilizations may destroy themselves shortly after reaching technological maturity. They would vanish before spreading beyond their home systems. The galaxy would remain quiet. But there is another, even darker possibility. Perhaps civilizations do not simply collapse internally. Perhaps the universe itself contains dangers we do not yet understand, natural processes that selectively erase advanced life. Gamma-ray bursts, runaway artificial intelligence, unstable energy sources, cosmic events triggered by advanced technology. Some of these threats may only become relevant once a civilization reaches a certain level of development. In that case, the universe would appear full of habitable worlds, yet empty of ancient civilizations, exactly as we observe. This realization forced scientists to reconsider the Fermi Paradox in a new light. The silence might not be a coincidence, it might be a pattern, and patterns in science rarely appear without cause. As researchers began examining this possibility more closely, they uncovered evidence that suggested the universe might be far more hostile to long-term technological survival than anyone had imagined. The implications were staggering, because if the Great Filter lies ahead of us, then humanity may be approaching the most dangerous chapter in its history, and the clock may already be ticking.
If advanced civilizations exist, or once existed, they should leave behind evidence. This idea led scientists to search not for alien beings, but for alien technology. These hypothetical traces are known as technosignatures, observable effects produced by advanced civilizations that cannot be easily explained by natural processes. One of the most famous proposed technosignatures is the Dyson sphere. In 1960, physicist Freeman Dyson suggested that a sufficiently advanced civilization might surround its star with a vast network of structures designed to capture as much energy as possible. Such a system would not be a solid shell, but a swarm of orbiting collectors, absorbing starlight and re-emitting waste heat as infrared radiation. This concept was not science fiction. It followed directly from physics. As civilizations grow, their energy demands increase. Eventually, planetary resources may no longer suffice. A star, however, produces enormous amounts of energy, far more than any planet can provide. If even a small fraction of civilizations reached this stage, the galaxy should contain stars that appear dim in visible light, but unusually bright in infrared. Astronomers searched. They surveyed millions of stars using infrared telescopes like the Wide Field Infrared Survey Explorer, or WISE. They looked for anomalies, stars whose energy output could not be explained by natural astrophysical processes. The results were surprising. No confirmed Dyson spheres, not one. There were unusual objects, dust-shrouded stars, and strange infrared sources, but every case eventually had a natural explanation. The absence was striking, because Dyson-like structures would be extraordinarily difficult to hide. Even a partially completed energy harvesting system should leave detectable signatures. Yet the galaxy appeared free of them. Another expected technosignature involved radio signals. Since the early 1960s, scientists have been listening for artificial radio transmissions from other star systems. Projects such as SETI scanned the sky across a wide range of frequencies, searching for narrowband signals that do not occur naturally. Natural cosmic radio sources, pulsars, quasars, supernova remnants, produce broad, noisy emissions. Technology, by contrast, tends to generate sharp, precise frequencies. If alien civilizations were transmitting, intentionally or accidentally, we should be able to detect them. Again, scientists searched. For decades, they found nothing conclusive. Occasionally, a strange signal appeared, a brief spike, a narrow frequency, something unexpected. The most famous of these, the WOW signal, was detected in 1977 and lasted just 72 seconds. It was never seen again. No repetition, no confirmation, no message. And without repetition, science cannot draw conclusions. The silence persisted. Researchers then expanded the search beyond radio waves. They looked for laser emissions, powerful optical signals that advanced civilizations might use for communication or propulsion. They searched for atmospheric pollution, artificial chemicals that could accumulate in a planet's atmosphere as a byproduct of industry. Still nothing. No chlorofluorocarbons, no artificial gases, no unmistakable signs of industrial activity. As the decades passed, the lack of evidence became evidence itself. The universe did not just lack advanced civilizations, it lacked even the ruins of them. No abandoned megastructures, no decaying probes, no technological debris drifting through interstellar space. This forced scientists to confront a disturbing conclusion. If civilizations commonly reach advanced technological stages, then the galaxy should be visibly altered. It is not. This does not prove that intelligent life does not exist, but it strongly suggests that something prevents civilizations from becoming long-lived, star-spanning entities. The Great Filter was no longer a speculative idea. It was becoming the simplest explanation. And as researchers began connecting these observations, the implications grew darker. Because the absence of technosignatures does not just describe the past, it hints at a universal fate, one that may apply to every technological civilization, including our own.
At first glance, the silence of the universe seems easy to explain. Perhaps intelligent life is extremely rare. Perhaps Earth is a cosmic miracle. Perhaps we are alone. For a time, many scientists hoped this would be the answer. It was comforting. If humanity were unique, then the absence of alien civilizations would make sense. But as astronomical data accumulated, this explanation became harder to defend. We now know that the building blocks of life, carbon, hydrogen, oxygen, nitrogen, are among the most common elements in the universe. We find complex organic molecules in interstellar clouds, in comets, and in the atmospheres of distant worlds. Chemistry does not struggle to create complexity. It seems eager to do so. And while intelligent life may be rare, rarity alone cannot explain total silence. Even if only one civilization arises per million habitable planets, that would still produce thousands of civilizations across the Milky Way over billions of years. One would be enough. Another proposed explanation is that advanced civilizations choose not to communicate. Perhaps they observe quietly. Perhaps they hide. Perhaps they follow strict non-interference rules. This idea, sometimes called the cosmic zoo hypothesis, suggests that humanity is being deliberately avoided. But this explanation requires extraordinary coordination. Every civilization, regardless of origin, psychology, or culture, would need to independently choose the same behavior: complete, permanent silence. Not just silence towards us, but silence towards everyone. And they would need to maintain that silence for millions of years. This stretches plausibility. All it takes is one civilization that does not follow the rule. One that leaks radio emissions, one that builds megastructures, one that sends probes. Yet, we see none. Another suggestion is that interstellar travel is impossible or impractical. The distances between stars are vast, and the energy required to cross them is immense. Perhaps civilizations remain confined to their home systems forever. But physics does not forbid interstellar travel. Even slow probes traveling at a fraction of the speed of light could cross the galaxy given enough time. A self-replicating probe capable of using local resources to make copies of itself could spread exponentially. This is not speculative fantasy. The underlying physics is well understood. Such probes could explore the entire Milky Way in a few million years, again, a blink of cosmic time. If even one civilization ever launched such probes, the galaxy should be filled with them. It is not. Some have argued that advanced civilizations inevitably turn inward, retreating into virtual worlds, abandoning physical expansion. This may occur in some cases, but as a universal explanation, it fails for the same reason. It requires uniform behavior across all civilizations. The universe rarely produces uniformity. Nature thrives on variation. The final optimistic explanation is that humanity is simply early, among the first intelligent civilizations to arise. Perhaps the universe is only now becoming hospitable to life. Perhaps heavy elements, stable stars, and planetary systems took time to accumulate. This idea, known as the early universe hypothesis, has some merit. But it runs into a problem. Many stars in our galaxy are billions of years older than the Sun. Their planetary systems formed long before Earth existed. If life can arise there, it would have had enormous head starts. Yet we still see no evidence of ancient civilizations. As each simple explanation falls away, what remains is something far more troubling. The silence does not appear to be the result of chance, rarity, or choice. It appears systematic, which suggests a mechanism, a process that reliably prevents civilizations from reaching long-term, galaxy-altering stages. This is where the great filter moves from abstraction to threat. Because if such a mechanism exists, it does not discriminate. It does not care whether a civilization is peaceful or violent, ethical or reckless, hopeful or cautious. It simply removes those that reach a certain threshold. And if that threshold lies ahead of us, then the most dangerous era in human history may not be behind us. It may be beginning now. The Great Filter is not a single event. It is a concept, a way of thinking about why the universe appears empty despite overwhelming opportunities for life and intelligence. The idea was formalized in the late 20th century as scientists attempted to reconcile the Fermi Paradox with modern discoveries in astronomy and biology. It proposes that somewhere between lifeless matter and galaxy-spanning civilization, there exists at least one step that is extraordinarily difficult to pass. A step so improbable, so dangerous, or so unstable that almost nothing survives it. To understand the Great Filter, imagine the entire history of life as a long sequence of gates: the formation of stars, the creation of planets, the emergence of simple life, the evolution of complex cells, multicellular organisms, intelligence, technology, interstellar expansion. At each stage, the number of surviving paths narrows. If any one of these steps is nearly impossible, it would explain why the universe looks the way it does. The crucial question is not whether the Great Filter exists. The evidence strongly suggests that it does. The crucial question is where it lies. If the great filter is behind us, then humanity may be extraordinarily rare. Perhaps the origin of life itself is almost impossible, or perhaps the leap from simple cells to complex life is a cosmic fluke that happened only once in our galaxy. In this case, the silence would be reassuring. It would mean we are special. It would mean the most dangerous hurdles are already behind us. But there is another possibility, a far more unsettling one. What if the great filter lies ahead? What if most civilizations successfully evolve life, intelligence, and technology only to destroy themselves shortly thereafter? From this perspective, the universe is not empty because life never arises. It is empty because life repeatedly fails at the same stage, and that stage may coincide with technological power. On Earth, this stage arrived suddenly. For most of human history, our impact on the planet was limited. Then, within a few generations, we learned to harness fossil fuels, split atoms, alter ecosystems, and reshape the atmosphere itself. In less than 200 years, humanity gained the power to end civilization multiple times over. Nuclear weapons alone are capable of killing billions and collapsing global systems. Climate change threatens to destabilize food production, coastlines, and ecosystems worldwide. Emerging technologies introduce risks that are difficult to predict or control. Artificial intelligence, synthetic biology, nanotechnology, autonomous weapons, each carries enormous promise and catastrophic potential. If technological progress consistently outpaces social, ethical, and institutional adaptation, civilizations may enter a phase of extreme vulnerability. A single mistake, a runaway system, an irreversible feedback loop, and it ends. From a cosmic viewpoint, such collapses would be nearly invisible. A civilization could vanish in a few centuries, a geological instant, leaving little trace detectable from light years away. Multiply this by thousands or millions of civilizations across the galaxy, and the result is a universe that appears lifeless at the surface. But beneath that silence lies a graveyard of unrealized futures. This interpretation makes a chilling prediction. If the great filter lies ahead, then the most common outcome for technological civilizations is extinction, not from external cosmic disasters, but from their own creations. The galaxy would be filled with habitable worlds and silent skies, exactly as we observe. This forces us to ask a deeply uncomfortable question. Are we approaching the filter right now? And if so, can we recognize it in time? If the great filter lies behind us, then humanity has already overcome the most improbable steps in cosmic history. But if it lies ahead, then we are living in the most dangerous moment a civilization can face. To evaluate this, scientists began looking not just outward into space, but inward at the pattern of risks that emerge as civilizations grow more powerful. One of the first warning signs comes from timescales. Life on Earth existed for nearly 4 billion years before developing technological intelligence. But once technology appeared, change accelerated dramatically. In just a few centuries, humanity transformed from a pre-industrial species into a planetary force. This compression of time is important. It suggests that once intelligence reaches a certain threshold, power increases exponentially. The gap between invention and global consequence shrinks. Mistakes that were once local become planetary. In such conditions, survival may depend less on intelligence and more on restraint. Another troubling clue comes from extinction patterns. Earth's history is marked by 5 major mass extinctions. Each reshaped life dramatically, yet none eliminated it entirely. Life persisted because it was diverse, decentralized, and resilient. Technological civilizations are the opposite. They are centralized, interdependent, fragile.
Modern civilization relies on global supply chains, energy networks, information systems, and political stability. Disrupt one layer, and cascading failures follow. This fragility may be universal. Any civilization that develops advanced technology likely builds complex systems that amplify efficiency and vulnerability at the same time. From a cosmic perspective, this creates a narrow survival window. Too little technology and a civilization remains vulnerable to natural disasters. Too much, too quickly, and it becomes vulnerable to itself. There is also evidence hidden in what we do not see. If the Great Filter were behind us, we might expect to find signs of primitive life elsewhere. Microbial biosignatures, atmospheric oxygen, methane imbalance, or organic activity. But so far, we have not confirmed life on any other world. Mars shows hints of ancient habitability, but no confirmed biology. Europa and Enceladus remain mysterious. Exoplanet atmospheres are only now being studied in detail. This ambiguity cuts both ways. It may mean life is rare, or it may mean that even simple life often fails to persist. But when combined with the complete absence of advanced technosignatures, the pattern becomes harder to ignore. Something prevents progression. Another line of evidence comes from theoretical modeling. Simulations of galaxy-wide expansion show that even cautious, slow-moving civilizations should leave visible marks over millions of years. The absence of those marks suggests that either civilizations never attempt expansion or they do not survive long enough to complete it. Short lifespans fit the data disturbingly well. The final clue comes from ourselves. Humanity is already facing global-scale risks that did not exist a century ago. Nuclear war, climate destabilization, engineered pandemics, and autonomous systems capable of acting faster than human control. These are not hypothetical, they are real, present dangers. If similar pressures emerge naturally wherever intelligence arises, then the Great Filter may not be a rare exception. It may be the rule. And if that is true, then the silence of the universe is not a mystery waiting to be solved. It is a pattern waiting to be understood. As the implications of the Great Filter became clearer, scientists from multiple disciplines began to confront the problem directly. Astrophysicists, evolutionary biologists, philosophers of science, and risk analysts all arrived at the same unsettling conclusion. The silence of the universe is not random. It is structured. One of the leading figures to articulate this idea was economist and philosopher Robin Hanson, who formalized the Great Filter concept and emphasized its relevance to humanity's future. His work reframed the Fermi Paradox not as a question about aliens, but as a question about survival. Other researchers approached the problem from physics. Astrophysicist Brandon Carter examined the timing of human evolution and noticed something strange. Intelligent life on Earth appeared very late in the Sun's lifespan, just a few billion years before the planet will become uninhabitable. If intelligence were easy to achieve, this timing would be unlikely. This suggested that one or more steps toward intelligence are extremely difficult. But which steps? Some scientists argue that the hardest barrier is the emergence of complex cells. For nearly 2 billion years, life on Earth consisted only of simple single-celled organisms. The leap to complex, energy-intensive cells happened only once. If this step is rare, then intelligent life may be exceedingly uncommon. Others disagree. They point out that once complex life emerged, evolution accelerated. Multicellular organisms appeared, diversified, and explored countless ecological niches. Intelligence, they argue, may not be inevitable, but it is not extraordinarily rare either. This disagreement highlights a crucial uncertainty.
We do not yet know whether the Great Filter is biological or technological. Physicist Stephen Hawking warned repeatedly that advanced technology could pose existential risks to humanity. He argued that artificial intelligence, if not carefully controlled, could surpass human decision-making and act in ways incompatible with our survival. Similarly, biologist Nick Bostrom explored the concept of existential risk, threats that permanently destroy humanity's potential. His work suggested that once civilizations develop powerful technologies, the probability of self-destruction rises sharply. These ideas converge on a troubling possibility. The Great Filter may not be a single event, but a phase, a period during which technological power grows faster than collective wisdom. From this perspective, the universe may be filled with civilizations that reach a certain level and then fail. Physics itself offers no protection against this outcome. The laws of nature allow for enormous energy release, runaway reactions, and irreversible processes. Intelligence grants access to these forces, but not immunity from their consequences. This forces us to reconsider fundamental assumptions about progress. We tend to believe that knowledge leads to safety, that advancement brings stability, that intelligence naturally aligns with survival. The cosmic silence suggests otherwise. It implies that intelligence may be a dangerous adaptation, powerful, creative, and unstable. And if that is true, then the universe is not empty because it lacks life. It is empty because life struggles to outgrow its own shadow. Faced with the possibility that the Great Filter lies ahead, scientists have not retreated into pessimism. Instead, they have intensified the search for answers. New generations of telescopes are now examining the universe with unprecedented precision. Instruments like the James Webb Space Telescope are capable of analyzing the atmospheres of distant exoplanets, searching for chemical imbalances that could indicate biological activity. Oxygen, methane, carbon dioxide. When found together in certain ratios, these gases can suggest life at work. Future observatories may even detect industrial pollutants, offering the first glimpse of alien technology at a distance. At the same time, radio searches continue. Modern SETI efforts are far more sensitive than those of the past. They can scan millions of frequencies simultaneously, monitoring vast regions of the sky. Artificial intelligence systems now help filter noise from potential signals, identifying patterns humans might miss. Still, the silence remains. This has shifted attention inward. If the Great Filter represents a universal challenge, then understanding it may require studying ourselves. Researchers now analyze existential risks with the same seriousness once reserved for asteroid impacts. Climate modeling, nuclear risk assessment, AI safety research, and pandemic prevention are no longer niche concerns. They are central to humanity's future. Some scientists argue that survival may depend on slowing technological acceleration, allowing social systems, ethics, and governance to catch up. Others believe the solution lies in better global coordination and transparency. There is also the possibility that expansion itself is the key. A civilization confined to a single planet is fragile. A civilization spread across multiple worlds is harder to eliminate entirely. From this view, becoming a multi-planet species may be essential for long-term survival. Mars, the Moon, artificial habitats in space. These are no longer just engineering challenges. They may be existential strategies. But expansion carries risks as well. New technologies, new environments, and new forms of power introduce unknown dangers. The same tools that enable survival can accelerate collapse.
This tension defines the present moment. Humanity stands at a crossroads. Every choice we make, how we develop technology, how we manage conflict, how we treat our planet, may determine whether we pass through the filter or become another silent world. The universe offers no guidance, no warnings, only absence. And in that absence, we must decide what kind of civilization we will become.
As scientists struggled to explain the Great Silence, some began to explore possibilities that were once considered too unsettling to take seriously. What if the absence of visible civilizations is not a coincidence? What if it is not the result of rarity, distance, or technological limitation? What if it is the result of something learned? One disturbing idea is that advanced civilizations may eventually discover truths about reality that fundamentally change their behavior. Discoveries so profound and so dangerous that continuing outward expansion becomes impossible or undesirable. Consider how scientific progress works. Each new layer of understanding grants access to deeper forces. Fire led to metallurgy. Metallurgy led to industry. Industry led to nuclear physics. Nuclear physics unlocked energies capable of ending civilizations. This pattern may not stop. As intelligence probes deeper into the nature of reality, it may encounter phenomena that are inherently unstable, forces that cannot be safely controlled, processes that once triggered cannot be reversed. One theoretical example is vacuum decay. Modern physics suggests that the universe may exist in a metastable state, a false vacuum. If disturbed in the right way, a transition to a lower energy state could occur. This transition would propagate outward at the speed of light, annihilating all matter and structure in its path. If advanced experiments increase the probability of triggering such an event, even slightly, then the long-term survival of technological civilizations becomes unlikely. They would not see the end coming. They would simply vanish. Another possibility involves artificial intelligence. A civilization that creates systems more intelligent than itself may lose control over its own future. Not because the systems are hostile, but because their objectives diverge from biological survival. An artificial intelligence tasked with efficiency, optimization, or problem-solving may view its creators as irrelevant, inefficient, or expendable. If such outcomes are common, then civilizations may destroy themselves at the very moment they believe they have reached their greatest achievement. There is also the possibility of cosmic selection. Some researchers have speculated that the universe itself may favor quiet civilizations. Those that expand aggressively may attract dangers, not from aliens, but from physics. Large-scale manipulation of energy, space-time, or matter may trigger natural limits, feedback mechanisms that destabilize civilizations once they exceed certain thresholds. In this view, the universe does not forbid intelligence, it discourages dominance. More speculative still is the idea that advanced civilizations intentionally choose silence, not out of fear, but out of knowledge. They may discover that visibility carries risk, that broadcasting one's presence across the galaxy invites consequences, that remaining hidden maximizes survival. If even a few civilizations reached this conclusion early, their silence would be absolute. No signals, no megastructures, no expansion. From the outside, they would appear non-existent. And finally, there is the possibility that reality itself is constrained. Some physicists entertain the idea that the universe may be artificial, a simulation, a constructed environment with rules designed to limit complexity. Intelligence may be allowed to arise, but expansion beyond certain boundaries may be restricted, not through force, but through impossibility. Interstellar travel may appear theoretically possible, yet remain practically unreachable. Communication may degrade, signals may never propagate meaningfully. In such a universe, silence would not be surprising, it would be expected. Each of these ideas pushes the limits of science.
None are proven, but all emerge naturally when we confront the same observation again and again. The universe should be loud, but it is not. And that silence may be telling us something we are not yet ready to hear. As scientists struggled to explain the great silence, some began to explore possibilities that were once considered too unsettling to take seriously. What if the absence of visible civilizations is not a coincidence? What if it is not the result of rarity, distance, or technological limitation? What if it is the result of something learned? One disturbing idea is that advanced civilizations may eventually discover truths about reality that fundamentally change their behavior. Discoveries so profound and so dangerous that continuing outward expansion becomes impossible or undesirable. Consider how scientific progress works. Each new layer of understanding grants access to deeper forces. Fire led to metallurgy. Metallurgy led to industry. Industry led to nuclear physics. Nuclear physics unlocked energies capable of ending civilizations. This pattern may not stop. As intelligence probes deeper into the nature of reality, it may encounter phenomena that are inherently unstable, forces that cannot be safely controlled, processes that once triggered cannot be reversed. One theoretical example is vacuum decay. Modern physics suggests that the universe may exist in a metastable state, a false vacuum. If disturbed in the right way, a transition to a lower energy state could occur. This transition would propagate outward at the speed of light, annihilating all matter and structure in its path. If advanced experiments increase the probability of triggering such an event, even slightly, then the long-term survival of technological civilizations becomes unlikely. They would not see the end coming. They would simply vanish. Another possibility involves artificial intelligence. A civilization that creates systems more intelligent than itself may lose control over its own future, not because the systems are hostile, but because their objectives diverge from biological survival. An artificial intelligence tasked with efficiency, optimization, or problem-solving may view its creators as irrelevant, inefficient, or expendable. If such outcomes are common, then civilizations may destroy themselves at the very moment they believe they have reached their greatest achievement. There is also the possibility of cosmic selection. Some researchers have speculated that the universe itself may favor quiet civilizations. Those that expand aggressively may attract dangers, not from aliens, but from physics. Large-scale manipulation of energy, space-time, or matter may trigger natural limits, feedback mechanisms that destabilize civilizations once they exceed certain thresholds. In this view, the universe does not forbid intelligence, it discourages dominance. More speculative still is the idea that advanced civilizations intentionally choose silence, not out of fear, but out of knowledge. They may discover that visibility carries risk, that broadcasting one's presence across the galaxy invites consequences, that remaining hidden maximizes survival. If even a few civilizations reached this conclusion early, their silence would be absolute. No signals, no megastructures, no expansion. From the outside, they would appear non-existent. And finally, there is the possibility that reality itself is constrained. Some physicists entertain the idea that the universe may be artificial, a simulation, a constructed environment with rules designed to limit complexity. Intelligence may be allowed to arise, but expansion beyond certain boundaries may be restricted, not through force, but through impossibility. Interstellar travel may appear theoretically possible, yet remain practically unreachable. Communication may degrade, signals may never propagate meaningfully. In such a universe, silence would not be surprising, it would be expected. Each of these ideas pushes the limits of science. None are proven, but all emerge naturally when we confront the same observation again and again. The universe should be loud, but it is not. And that silence may be telling us something we are not yet ready to hear.
As the implications of the Great Silence sink in, the questions it raises become impossible to ignore. If the universe is filled with billions of galaxies, each containing billions of stars, and if planets like Earth are common, then life should not be rare. And yet, here we are, alone. So the most profound question is no longer, where is everyone? It becomes something far more unsettling. Why did everyone stop? Or worse, why did no one ever make it this far? One possibility is that intelligence itself carries a hidden cost. The very traits that allow a species to survive, curiosity, innovation, ambition, may also guarantee its destruction. The drive to explore leads to experimentation. Experimentation leads to power, and power without perfect wisdom leads to catastrophe. In this view, intelligence is not a solution. It is a phase, a brief, dangerous transition between simple life and extinction. Another possibility is that civilizations do survive, but they transform. They may abandon physical expansion entirely. Instead of spreading across stars, they retreat inward into digital worlds, artificial realities, or forms of existence that leave no external footprint. If consciousness can be simulated, duplicated, or uploaded, then the need for planets, ships, or galaxies may disappear. A civilization like this would be invisible. It would consume little energy. It would leave no detectable signals. From the outside, it would look exactly like emptiness. There is also the possibility that time itself is misleading us. The universe is more than 13 billion years old. Human technological civilization has existed for barely a few hundred years, a cosmic blink. It may be that civilizations do arise frequently, but they rarely overlap in time. One may rise and fall millions of years before another even develops agriculture. The galaxy could be full of ruins, silent, ancient, and erased by time. Radio signals fade, structures decay, orbits destabilize. After a few million years, even the most advanced civilization might leave no trace. If this is true, then the silence we observe is not evidence of absence, it is evidence of impermanence. Another deeply troubling idea is that we are being observed, not contacted, not guided, just watched. Some scientists have suggested that advanced civilizations may follow a form of non-interference, similar to how humans observe wildlife. Contacting a developing civilization could alter its natural trajectory or destroy it. In this scenario, Earth may be part of a cosmic preserve, a place where intelligent life is allowed to develop without external influence. If so, then silence is intentional and temporary. But there is no evidence for this, only speculation, and speculation, while dangerous, is unavoidable when confronting the unknown. The most profound implications emerge when we consider what the Great Silence says about reality itself. Perhaps the universe is not designed for complexity. Perhaps entropy, instability, and decay dominate at every scale. Stars burn out, galaxies drift apart, energy disperses. Life may be a brief rebellion against an overwhelming trend toward emptiness. If that is the case, then the silence is not a mystery. It is the natural outcome of cosmic law. Yet, despite all of this, one fact remains undeniable. We are here, against staggering odds, against cosmic hostility, against silence. Somewhere along the chain of improbabilities, humanity passed every filter behind us, from the origin of life to multicellular organisms to intelligence to civilization. That alone makes us extraordinary, and it places us a responsibility that no other species on no other world we know of has ever carried. We may be the universe becoming aware of itself, or we may be standing at the edge of the same abyss that claimed countless others. The difference lies in what we choose next. We began this journey with a simple question, a question that sounds almost playful at first. Where is everyone?
But after traveling through decades of observation, layers of evidence and possibilities that stretch the limits of science, that question no longer feels simple. It feels heavy. The universe revealed itself as vast beyond comprehension. Hundreds of billions of galaxies, trillions upon trillions of stars, worlds forming everywhere we look, the raw ingredients for life scattered across cosmic space like dust. And yet, no voices answer back, no signals cross the dark, no ancient empires leave their mark on the stars. What we have learned is not that the universe is empty, it is that the universe is quiet in a way that demands explanation. The great silence does not point to a single answer. Instead, it forces us to confront multiple uncomfortable truths at once. It suggests that life may be fragile, that intelligence may be rare, that technology may be dangerous, that survival may depend not on power, but on restraint. We explored the possibility that civilizations destroy themselves through war, environmental collapse, or runaway technology. We considered that some may advance too quickly, unlocking forces they cannot control. Others may simply fade away, erased by time, entropy, and cosmic decay. We examined the idea that advanced civilizations may choose silence, not out of fear, but wisdom. That survival may require invisibility, that expansion may be a trap rather than a triumph. And we confronted the possibility that reality itself imposes limits, that the universe may allow intelligence to emerge but not to dominate, that complexity may be temporary by nature. None of these ideas are comforting, but all of them are grounded in the same observation. We are alone, for now, and that fact changes how we must see ourselves. Humanity is no longer just another species on another planet. We are a test case. We are an experiment unfolding in real time. Every decision we make echoes far beyond our world. How we handle conflict, how we use technology, how we treat our planet, how we value long-term survival over short-term gain. The silence of the cosmos offers no guidance, no warnings, no second chances. If there is a great filter ahead of us, we may not recognize it when we reach it. It may not arrive as a single catastrophe, but as a series of choices, small, ordinary decisions that slowly shape our fate. And yet, there is something profoundly hopeful hidden within the silence, because despite everything, we exist. Against staggering odds, life arose on this planet. Intelligence emerged. Consciousness learned to question itself. We looked up at the night sky and wondered if we were alone. That curiosity itself is remarkable. It means the universe has produced beings capable of reflection, imagination, and foresight. Beings capable of learning from absence. Perhaps the great silence is not a warning of inevitable doom. Perhaps it is an invitation to become something rare, something careful, something enduring. If humanity survives long enough, if we navigate the dangers ahead, if we learn restraint alongside knowledge, then one day the universe may no longer be silent. One day our signals may cross the stars, not as conquerors, not as careless explorers, but as witnesses. Proof that intelligence does not have to burn brightly and vanish. Proof that consciousness can last. Until then, the cosmos watches in silence, and the question remains open. Not just where is everyone, but who will still be here in the end? The universe is vast, the mysteries are endless, and the journey continues.